Hi, algorithm writer. Hope things are fine with you. Let's take a look at dynamic array, very practical data structure. It is dynamic array. All right. So the first thing we want to do with the dynamic array is understand it. And these are all very short chapters, but especially the logic chapter, that's going to tell us about the dynamic array, what it is. So we want to go through these. They're basically all one pagers, so they're short. Write some sketches as we go. Us coders, we don't really read per se. We sort of sketch as we go to get understanding, to dig in. So if you haven't done that, maybe stop this video and do that a little bit, and then come back. And it's all iterative. We're not going for perfect understanding. We'll get some understanding, and we'll do it iteratively. So let's continue on here. Another thing I just want to mention here is this here too. You're used to these ADTs, I think, or we're getting familiar with those. We'll get more familiar as we go. They are like a Java interface as an example. They tell us what we need to code, right? So this is what we need to code for this thing we're coding, this model we're coding today. We're coding size is empty, get, first, last, list type methods, right? List type things. So let's get to the some coding. All right, the first thing that's nice to start off with is the object structure. What is that object structure going to look like? And if we go through these, we see that we took a couple shots at it. We took an initial shot at it. We ended up with this object structure. And our final shot, we ended up with this, right? 4 instance variables. The primary one is the fixed array. We're wrapping a fixed array. Why? Because we want to have the speed of that fixed array. All right, so let's go to the coding. Very simple, normal class declaration there. Then we have our ibars here, and this is pseudocode or algorithm thinking here, and this can be converted to a real language, but we're just listing the ibars in our pseudocode. We have our fixed array, primary ibar, and then we have some support ibars. We need size, for example. The methods, let's start off with a couple of real simple methods. It's always nice to start off with simple, and we test as we go, Size, all we're going to do is return that ibar. Now it's not magic. That's not going to be correct automatically. We need to do bookkeeping on that ivar as we code, right? For example, when we add an element into this list, we'll want to increment size. If we remove an element from this list, we'd want to decrement the size ivar, right? But in terms of just returning the size, which is all this is telling us to do, let's go back really quickly to the list ADT. It tells us, we need to return the number of elements. So it's just returning the number of elements. This is empty. We're going to actually leverage size. We'll just call it. And when that's equal to 0, we know we're empty, right? And when that's true. So we'll return true when that's empty. So here's a little test. We construct an empty dynamic array here, right? There's an empty array. And again, this is pseudocode. This is algorithm thinking here. And we're just going to print if it's empty or not. So let's give it a run. And it's right. Now, do we dare try it though with elements? 10, 20, a couple elements. We would expect that to be 2, but we actually get an error up here. Dynamic, the add is not. So we haven't coded that up yet. That's why we're getting an error there. So we would continue on and work some more magic here. And let's get some more code in here. We would. Let's try get, for example, is a nice simple method because we're wrapping that guy, right? So when we're getting an element, get tells us, what does get want us to do? Get wants us to return the element at the given index. That just means that we're going to take that fixed array and then return the element at that fixed array, that index, right? We're going to basically just delegate to the fixed array. And here's our exception handling here. We want to add that in too. We're going to check the index, make sure it's within bounds, 0 to size minus 1, right? That's a little helper method. I really suggest helper methods to do that kind of work. And then we're going to throw an exception here if it's not a good index. So we could try get here. Let's see here. Let's do a get on element number 1. and that would be dynamic array get, right? Get 1. That should return index 0. Index 1 is the 20, right? So we would expect 20 to print out here, and we did. So that is working. First, very even simple. We can just actually, again, we can call one method, call another method. We've already coded this one, done a little test. We don't want to do more testing, but we're kind of confident in that get method, so why not just call it from here, right? Get 0 would be first. And then, of course, we don't have it here, but last would be very similar to this method, of course. Find first method. We can do that in a couple ways. This is a nice, easy way to do it. If you do implement an iterator, you could do it like this. The beauty of this, you'll see that there's no use of indexed access like here, because our sibling, a linked list, when we later code a linked list, this might not be a very efficient method to use. It is not, hint, hint. So this here doesn't use that. So it's a generalized approach, right? So this could be pushed up, hint, hint, into a superclass, right? We could have a superclass for dynamic array and linked list. They could have a superclass that would use this method and many more methods, actually, especially that use this iterator. So helpful, this iterator. And the iterator, you'll see there is discussion of that, and the problem write-up talks about it too, but just to show you again, the iterator right here, there's videos on that, and it's not a real long read again, it's a pretty short read. Super fun, super helpful. What else do we want to look? Add. Again, we're calling methods all over the place. You'll notice I do that because I don't want to write the same thing again and again and again. I'd rather just call something that's already done, right? So add last is a very specific method, right? We know that add is doing the same thing as add last. How do we know that? Well, we would just go down to our ADT, which has the rules, and it says it's an alias for add last. All it is an alias, another name for add last, just convenience method. So we're calling it here. And then for add last, what we're doing here is basically just using, again, the fixed array, and we're adding one position to the current last index. That's just a helper method, the last index that we currently have, and we're adding 1. Or you could actually use size here, couldn't you? Size is 1 past the last index, so we could actually just use the size here would also work, and that. And then we increment size, like we were talking before. We want to increment size. We want to manage that I-bar. This is going to be the fun part of the coding for this object. We want to check and adjust the capacity. If we don't have the capacity to add an element, in other words, we're full, our fixed array is full, we need to add capacity. So that's how that would work. So we could do some more testing then on that. Let's throw another test in here that we have available to us. We have a dynamic array here with a bunch of numbers. And let's see here. We're going to then print out, do a toString on it. Is empty. We're going to check that size, first matching, do a select statement. Let's give that a run, and there we go. All right, let's see, just one more thing I'll show you. Let's see what we have for select. There's select, and I use an iterator here. And again, iterator is optional. If you don't use iterator, it's not too much hard or anything. You just would use a for loop, right, with an index and the get method. We've done select actually a couple times in previous drills and assignments and such. So anyway, that's why I wanted to show you here some hints to kind of help get started. Basically, a lot of times the hardest part is just getting that object structure set up, and then you can kind of work with it. And to me, it's so nice getting a couple of methods going and then getting a test on those methods immediately, even if the tests fail, just to know that you've got some code that's crunching. Feels good, I think. All right, well, let me know if you have any questions. We'll talk to you soon. Bye-bye.